All right, we're on video number 5 of 6. As I mentioned in the last video, I said this one we're going to do the same type of problem. We've got a radical on one side, but this has an extraneous solution. You can't tell by looking at it until you get through solving it and look at your values that you get for x and plug them back into the original equation. We don't know if we have extraneous solutions. Well, you could graph them and you could see the solution, but we're not going to be putting these into our graphing calculator quite yet. All right, so again, isolate the radical. Radical's already isolated in this case. Now we want to raise both sides to a power that will eliminate the radical. I'm squaring both sides. Again, on the left-hand side, I squared a radical, so I get what's underneath the radical out. And on the right-hand side, I have x minus 8 times x minus 8, and I need to FOIL. X minus 6 equals x squared. My outside is minus 8x. My inside is minus 8x, so I get minus 16x plus 64. Again, we ended up with the quadratic, so we need to think about solving this by factoring. When we factor, we need to set our equation equal to 0. So I'm going to move the x, and I'm going to move the 6. Now it's set equal to 0. And on the right-hand side, I have x squared minus 17x plus 70. At this point, again, the steps to factoring, look for a GCF. There is no GCF, so I'm going to make my ACB chart. AC and B. AC is positive 70. B is minus 17. They were nice to us with this problem and made it a little bit obvious. 10 and 7, they both need to be negative. Minus 10 and minus 7 multiply back to a positive 70. Minus 10 and minus 7 add to a minus 17. A, my coefficient of the x squared, is 1, so I don't need to split the middle term. I have my factors, x minus 10 and x minus 7. I have my solutions. I set each factor equal to 0 and solve them. I'm going to skip that step. I've got x equal 10. And I've got x equals 7. Now at this point we need to check to make sure both of these are valid solutions. So we're going to plug them into the original equation and see what happens. Alright, my original equation was the square root of x minus 6 equals x minus 8. I'm going to plug in the two solutions I found when I solved. First one I'm going to plug in is 10. You should always check these. Square root of 10 minus 6 is equal to 10 minus 8. And I get the square root of 4 is equal to 2. That's a check. My second check for my second equation. Again, plugging it in, I'm going to plug in 7 minus 6 underneath the square root is equal to 7 minus 8. And right here is where my problem happens on the right hand side. I'm going to get that the square root of 1 is equal to a negative 1. At this point, you can't have a square root of a number, any number, and have it equal something that's negative. So this one causes a problem. So I'm going to, x equals 7 is a false solution, so we're going to cut that, cross that one off. The only valid solution to this equation is x equals 10. And when you solve these algebraically, sometimes that's going to happen. You're going to get a solution that doesn't check. It's a false answer. If I looked at these two on a graph, if I graphed x minus 6, the radical of x minus 6, and then in y1, and then I graphed x minus 8 in y2, I would see that they only intersect at the point where x equals 10. At x equals 7, we don't have a point of intersection. So the only solution that the graph would show me is x equals 10. Algebraically, we do get that second solution, and that's why we check to make sure that those are both real solutions.